Here we are going to do some practice questions on our recurrence relation. We'll go straight into it because we've already kind of talked about the formulas in the previous video. But this question says, just underlining the key features, Alyssa borrows $1,000. Now look for the key words. Anytime someone's borrowing something, we are thinking in terms of a loan. Now, we have an interest rate of 15% per annum. Key word here though is compounding monthly. And she will repay the loan by making 4 monthly payments of $257.85. Now, part A is saying construct a recurrence relation to model this loan in the form V of n plus 1 equals to Vn times 1 plus R minus D. Now remember, because it's a loan, we're taking away this because she owes $1,000 and she's paying it off. So it's taking away from the loan. That's why this is a minus and not a plus. Now, in order to, before we can kind of start and do anything, we need to consider, because this is compounding monthly, we have to change our interest rate. It's 15% per annum, but it's compounding monthly. So our rate, before we do anything, we have to take our percentage, convert it to a decimal, and divide it by 12. So this is going to give us a monthly interest rate. So that's going to be 0.0125 because it's compounding monthly. Now, our recurrence relation is V of n plus 1 equals to Vn. And we are multiplying this by 1 plus 0.0125. And we are minusing 257.85. So just to clean this up a little bit, our recurrence relation, we can write this as V of n plus 1 equals to Vn times 1.0125 minus 257.85. That's our part A. So we are just setting up our recurrence relation. Part B is saying to use your calculator to determine recursively the balance of the loan after Alyssa has made each of the 4 payments. So here we are just substituting into our calculator and we are just taking our answer every time and then re-substituting back in. I'll show you how that will look though. So when we have our first, at the end of our first month, our V of naught, our initial amount on the loan is $1,000. So you have to take $1,000, we apply the interest to it, and then we take away 257.85, and that gives us $754.65. So this is our V1. That's what we mean by first here. The value in the second, the end of the second month, we take our previous amount. Remember, we are taking the previous amount into here and then applying the recurrence relation again. As we keep going, V of n plus 1 just becomes the next month as we go. So this, for the second, it's going to be 754.65 times 1.0125 minus 257.85. This gives us approximately, to 2 decimal places, $506.23. And you are just inputting this into your calculator. So every single time, this amount here from your previous year goes in place of the Vn, and then you continue the recurrence relation to figure out the amount left to pay that following year. So the third one, we take that amount, 506.23 times 1.0125 minus 257.85 gives you approximately 254.71. And then at the end of the fourth, we have that amount, 254.71 multiplied by 1.0125 minus 257.85. Now this gives you approximately 0.04. So there's 4 cents basically left at the end of the 4 months. Now, this is saying in part C, it's saying what is the balance of the loan, the amount she still owes after she has made 2 payments. So here we're just looking at this information that we've got here. At the end of the 2 payments, when she's made 2 payments, she has this much left to pay off. So we're just looking at our recurrence relation. So part C, after 2 months, she owes $506.23. Last part, and this part's a little sort of tricky to understand, but hopefully we'll be able to kind of make it easier for you. It's saying, is the loan fully paid out after the 4 payments have been made? If not, how much will the last payment have to be to ensure that the loan is fully repaid after 4 months? When you look at our recurrence relation, we saw that right at the end, there's still 4 cents to pay off. So the loan isn't fully paid out. So I'm just going to write here, no, there is still 0.04 left to pay. Now, we have agreed, this person has agreed with the bank to repay the loan by making 4 monthly repayments. So obviously, with how these work, you may not get, with how the numbers are and whatever amount you pick, you agree upon to pay, you may not necessarily pay it all off fully right on the last payment. If there's anything left to pay, like these 4 cents, that will just get tacked on to the last payment because you've agreed with the bank. This has to be repaid after making 4 monthly payments. So those 4 cents just get tacked onto the last payment. So we can say last payment equals your amount that you've agreed to pay off, the amount of your payments, plus the 4 cents. So the last payment is going to be $257.89. So this is how we can work with this for a loan. And in example 2, we're going to look at an investment, okay? So it's saying Spencer makes an initial deposit of $1,000 on an investment taken out over 1 year. Let's actually start underlining these. This is what you'd be doing in an exam. Initial deposit of $1,000 on an investment taken out over 1 year at a rate of 7.2 per annum compounded quarterly, and an additional deposit of $100 made each quarter. So it's saying complete the table below for the first 4 deposits and calculate how much interest has been earned over this time. So before we do anything, we have to be careful. It's saying that this is compounding quarterly. So before we do anything, we need to convert the rate. So our R is going to be 0.072 divided by 4 because it's compounding quarterly. And this gives you 0.018. Okay, and we know our R, we know our D, our amount that we're putting in is 100. And we know our V naught. It said he's initially made an initial deposit of $1,000. So that's going to be 1,000. So we have to, before we do anything, we have to write our recurrence relation. So here, it's saying it's an investment. So this is another keyword. Because it's an investment, we are using the recurrence relation where we add a D. So just rewriting it, and I encourage you to write it as well with every question, just so you remember it. We have 1 plus the rate plus D. Now here, we can just substitute in recursively to our formula, okay? But I can fill in a couple of these things. When it's the V of n plus 1, that is always going to be our V1, our very first thing we write in, because V naught is the initial amount. So if we want to find the amount at the end of the first period, our Vn is going to be the starting amount, so V naught. And our amount D that we're putting in is $100. And now we are using the recurrence relation to find the value at the end of the first payment being made. So we have our V1 is 1,000, which is our V0, times 1 plus 0.018 plus 100. And that equals 1,118. So this I'm going to write in here. Okay, next one. At the end of the second quarter, so I'll actually just write this in so you can see it. Because remember, at the end of each quarter, this amount is being put in. So at the second quarter, your V2 equals to the amount in the previous one, V1. Apologies. We have 1,118 times 1.018. All I've done here is I've just added these and just written it in my recurrence relation. And then we add 100. So our V2 equals to 1,238.12. Now let's write a couple of these things in. I've just done here everything I need for this second row. Now your V1 is 1,118. That's the one at the end of the previous quarter. Our amount we're putting in is still 100. And our V2 is 1,238.12. Okay, now we just keep going. So you can pause the video if you want to try this on your own, and you can check back in with me for the answer. But at the end of the third quarter, V3 is just going to be 1,238, our previous amount, at the end of the second quarter, times 1.018 plus 100. That gives us 1,360.41. Writing this into our table, our V2 was the amount previously, so 1,238.12. And then we have 1,360.41. And we're just using the recurrence relation. So fourth quarter, V4 equals 1,360.41 times 1.018 plus 100. And that gives you 1,484.90. And I'm filling this into the table. So the previous amount, V3, is 1,360.41 per 100. And then your V4 is 1,484.90. Okay, so we filled in the table and we have to now calculate how much interest has been earned over this time. So with annuities, this is the trickiest part, okay? Because what we've been given is a value, okay? So we have a value after this year has passed, after our 4 quarterly payments. But remember, our interest is just the extra amount that's been earned, right? So we have to consider a couple of things. We have to consider the deposited amount. That's 1,000. That doesn't get included in the interest, right? That's like our present value when we did investments and loans a few series ago. We also have to consider the extra for deposits. The extra 4 deposits, we had 4 of them, which were $100 each. Look, I've even got them here. 1, 2, 3, 4. They're extra deposits. They don't get counted as interest. They were just extra money that we put in. This kind of gets factored in when we have to calculate our interest when we think about annuities. So this was 4 times 100, which equals 400. So to calculate our interest when we think of annuities, our interest is equal to 1,484.90, the amount after the 4 payments, after the 4 quarters, the year, minus the principal, the original present value, the deposited amount, minus, again, 400, the extra deposits we made. Because the interest is just what we accrued on top of that, on top of the initial amount, on top of the extra things we deposited in. What makes an annuity grow more is the fact that because we're making extra deposits on top of this, it's interest that's charged on a higher amount. So it's helping our thing to grow more in terms of interest, but this doesn't actually get included as interest. This is still money that we are putting in. We've put in a total of 1,000 and then an extra 400. So our future value, our amount at the end of the year, takes into account, that's just what we have, and we have to take into account these two and subtract them. So that gives you $84.90. This is the interest earned at the end of the year. One year. But this is how we can work with these recurrence relations and figure out how much interest basically we have gained. We've done this with an investment in this particular example, and we can also do it with a loan as we've learned in the previous example. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.